are we just waiting for these like agents to get better and better and humans will have to do less and less in the loop? Or, you know, is it less dependent on the model's capability and more dependent on kind of the use case? Like where is it headed? Is there a limit to how much we can abstract away?
Hello and good morning from a hotel room in San Francisco. You're listening to Mixture of Experts, and I'm your host, Tim Huang. Each week, Mixture of Experts brings together a stellar group from research, engineering, product sales, and more to tackle and discuss the biggest trends in artificial intelligence. So this week on the show, we've got three stories. First, NVIDIA announced the launch of Nemotron 4 340B, an LLM specifically designed to aid in the creation of synthetic data. How big of a deal is it? And what does it say about the next stage of AI training? Second, we'll talk about recent developments for agents in the enterprise. Are agents a reality now? And what can we expect the biggest impacts to be? And third and finally, just earlier this week, former OpenAI chief scientist Ilya Sutskever launches a company, Safe Superintelligence Incorporated. What is it, and does it have a chance of becoming a new contender in the space? As always, I'm joined by an incredible group of panelists that will help us navigate what has been another action-packed week in AI. So joining us for the first time today, Maya Murad, product manager for AI Incubation. Maya, welcome to the show.
Thanks for having me.
And then we've got two veterans who are joining that we haven't seen for some time, but I'm very excited to have both of them back. Kate Soul is a program director for generative AI research. Kate, welcome back.
Hey, everybody. Great to be here.
And finally, Kush Varshney, who was part of the very first episode. So he's the OG for Mixture of Experts. He is an IBM fellow working on issues surrounding AI governance.
Yeah, OG, I guess it's a great designation.
Yeah, it's some kind of distinction. So Kush, welcome back. Well, great. So I think first story I really wanted to dive into was, I caught in the kind of constant, wave of papers and releases coming out, a launch that happened from NVIDIA late last week on Friday. And because it was a Friday launch, I think it kind of got lost in the news cycle, but I did want us to kind of focus on it. NVIDIA released a class of models called Nemotron 4 340B. And it's a set of models that are specifically designed for synthetic data generation. And I think it's so interesting because if you're not familiar with the background here, right, the way we train LLMs, get them to do their magic, a lot of it relies on data. And in the past, the way people have done this is literally getting lots and lots of real-world text to train and improve their models. And so, the dream of synthetic data, I think, is very fascinating. It's kind of like the idea that in the future, we actually won't even need text from the real world. It'll just be like stuff that another AI model generates. And I guess, Kate, I want to throw it to you first, because I know you've thought a lot about this area and been kind of doing some work in the space. I'm kind of curious, just as a first cut, like, why is NVIDIA getting into this area? I'm really kind of curious about why this kind of hardware company is saying, well, we're going to be launching these models, and one of the models we're launching is a synthetic data model. So I guess the first question I'd throw to you is, like, do you have any thoughts on that? Conspiracy theories, maybe not conspiracy theories, but just like why it is that they're investing in this space at all?
So, I think there's some more straightforward answers and then maybe some side answers on why they're working in this space. One example of what you might think of why NVIDIA is working here and released the 340B model into the open source is for synthetic data specifically, is because they're recognizing that no one wants to run inference on a 340 billion parameter model for real tasks. Like, the value of models this size, I think originally there was a lot of excitement. Everyone wanted to build as big a model as possible and see how far they could push the field. But the reality is, like, no one's actually going to go and deploy this in production and hit a 340 billion parameter model every single time you want to run inference. It's just too costly. But there is a lot of value in running inference on this model once, using the data that you create to train a much smaller model and then deploying that out in production. And so I think part of this might be just the field is starting to find new ways to create value out of these really big models they invested on early on, because they do take a while to train. But it actually makes a ton of business sense for NVIDIA too, if you think about it, because their customers need to get models hosted on their compute running as soon as possible. And what we're seeing is not the easiest, but one of the most exciting and most powerful ways to start to take models, improve them, use them for their use case, and get them out into the world and deploy them in production is to align them using synthetic data. So more and more customers are using and consumers are using synthetic data in order to actually take models and tune them for your use cases and for your tasks. And so if NVIDIA can help customers with that cycle and help get models out into production faster, ultimately that's going to create some good drag for their products.
Yeah, it's such an interesting dynamic. I think, particularly on that first point that you're making, is NVIDIA, like the company that I identify with, like really big compute, right? Like every release is like bigger and bigger, and the models that you can theoretically run on them are bigger and bigger and bigger. But I guess almost you're kind of saying here, NVIDIA is like conceding the reality that like most people actually are not going to be doing that. It's just like such an expensive thing, and so almost they have to win the synthetic data game, or in the very least kind of like support that use case, just because it isn't what most people are doing to create like the biggest models in the whole world.
Yeah, I mean, the model, if you look at the supported intended uses, it's not just intended for synthetic data generation. It's a perfectly reasonable chat model. It can be used for chat use cases. But if you look at how it's been marketed by NVIDIA, every single press release and blog and paper is all about the synthetic data aspect. And so I think they're recognizing that this really is the only viable way to try and get value out of models this size. And it's also a really exciting way. I mean, it's just where the field is headed and where people are seeing a lot of use and value.
Yeah, for sure. And Maya, I'm kind of curious if I can bring you into the discussion. So I think one of the reasons we want to bring you on is my understanding is that you've done a ton of work with kind of enterprises, right, and getting them to integrate new kinds of technology. I guess I'm kind of curious about what you're sort of seeing out in the space. Is like synthetic data becoming, a bigger part of the discussion? Do people want it? I'm just kind of curious about like what the market demand for this is looking like over time.
I think it's a very exciting space, and it's a need that existed prior to the rise of generative AI. So customers they have their own data, but they're also limited to it, and it's costly to create task-specific data. So there is a really strong premise of, can I start with only a few examples and augment that data set for various use cases, to train my own model, to evaluate on a use case, to red team. So there's a lot of value to be drawn out of it, and it's one of the top customer inquiries we get.
Yeah, that's really interesting. Yeah, I don't wonder if like in the future, I'm curious if any of the panelists kind of have a view on this, is like, we've so identified, and I think this has actually been certainly something on the policy side. People have been like, oh, AI is so data hungry, and so therefore it is kind of privacy invasive, right? Like it just needs all of this data to get working. Synthetic data for me has always been like, well, maybe in the future, like actually real world data is actually not going to be that big of a deal, because you have a few examples and then you scale up with synthetic and there you go. I mean, is that a fantasy? Are we headed to that world?
I mean, I think in terms of using synthetic data as a tool to protect privacy, it certainly has a lot of value. I don't think we've quite, there's a lot of work to be done in that space in order to really take advantage of the promise that it offers. But Maya mentioned that even before generative like LLMs became around, we've been using synthetic data. And I think that's very much true. Like we've looked at, for example, a couple of years ago, using synthetic tabular data just to create privacy protected versions of sensitive data sets where you can mask information. So there's a lot of different kind of really cool applications that I think are going to start to converge with synthetic data around privacy, how that impacts generative AI training, and maybe help drive this space forward more. I know, Kush, you do a lot of work in this space. Maybe you can comment.
Yeah, no, I mean, I think the privacy aspects are an important part of it. I think the exciting thing is actually going back to the fundamentals of probability. I know in the first couple episodes we covered Kolmogorov and other friends from that time, and just the ability to sample like really high dimensional spaces with just a few examples is like mind-blowing in some ways, even though it feels very normal. Like with 5 data points, you can sample this like trillion-dimensional space and cover it so well. Like, I mean, I think that's pretty crazy. So, yeah, I mean, this is just changing how work is done, I think, in the whole generative AI space.
Yeah, for sure. I think it's really, it's a really interesting way of sort of thinking about it. And yeah, I think we want to do more Kolmogorov type sections. Like it feels like that was actually really good for us to go so wonky. But I think it's actually important. I think in terms of like exposing, what's actually really going on under the hood. I mean, I guess, Kate, one question for you is, given that this has been long-term research objective, right? Do you see the Nemotron release as kind of largely sort of incremental? Like, is this a big deal, this launch? Or is it pretty much just like the most recent salvo in the race for synthetic data?
So honestly, I think what is the most exciting part about this release is the release of the model terms, where NVIDIA is actually saying we want this model to be used to train other commercially viable models, and we make no claims over models trained with synthetic data created by Nemotron, which is very different than almost any other model provider that's creating, especially ones creating their own custom model terms. If you look at like the Llama license, Gamma license, and others that are being created, they all prohibit that type of use. So the model itself is exciting, and I think people will start experimenting with it and seeing how far they can take it in the next couple of weeks. But what they did that is really totally different from how anyone else is behaving is actually the permissions in which it was released in.
It's like the legal terms are the real innovation here.
I'm sure there's lots of other innovation too, but that's the one I'm really excited about.
Yeah, for sure. And I think it's kind of, NVIDIA is kind of playing a dangerous game here, though, right? Because there's a bunch of people who are making these models proprietary because they want to build businesses at the synthetic data layer. I guess NVIDIA is kind of saying, like, we sort of don't care. Like, we would rather just have everybody have access to this, and, for us to sort of enable all the secondary commercial models rather than creating like a market around synthetic data specifically.
I mean, you got to use NVIDIA compute to generate synthetic data on a 340 billion parameter model. Then you have to use compute to train it, and then you have to use compute to host it. So I think they're playing a good long game there.
Yeah, I saw this great tweet recently, which is, the adage of like, oh, when there's a gold rush, everybody should be selling shovels. But it's almost kind of like NVIDIA's like, when everybody's selling shovels, you need to be selling shovel making machines. And I was like, that's actually like such a good way of kind of capturing what it is that they're doing in the space. There's a very broad topic I think we want to cover on this second agenda item, which is agents, right? This is like the jargon in the space shifts so quickly. It's like, it feels like a few months ago, people were like, oh, agents are coming. And then now it's kind of like agents are here and everybody's working on it. And I guess, Maya, I think part of the first thing I want to kind of bring you in on is just if you want to explain to our listeners, what are agents exactly? And like, why is it a jump from what we've had in the past? Because I think the definition and the distinctions have not always been so clear. And so I think even for me, I don't really know, but we're just like, as a good place to start, like, what are agents and why are they different?
Yeah, absolutely. So the way that I like to explain what are agents is to first contextualize where we are in terms of building applications with AI. So in 2022, all about foundation models, all about large language models. I think we've learned since that simply input and outputting from a model is not going to unlock those high impact enterprise use cases. So if I want to understand what is my vacation policy, or if I want to retrieve real data, I have to build a system around it. And actually, Berkeley came out with a really good paper this year talking about compound AI systems. And it's a reflection of the fact that you need to go back to plain old systems engineering to build AI applications. So modular components that are fit to solve certain problems. So you have retrievers, you have external tools, and then you have your model interacting with those to solve a problem. And we're still in this world, and agents still operate within the space of an AI system. The way most of AI systems are built, for example, retrieval augmented generation is one of the most popular kinds, is me as a developer, I prescribe the flow. So take the user query, run it through a search, retrieve the results, feed it a model, and then the model generates an answer. So this is a flow that has been pre-described and it's fixed. If I give it something else, it's not going to work because it was pre-described to solve problems maybe related to vacation policy. An agentic approach in a system is the LLM can reason through how to solve the problem and understand what is the path to chart to answer a query. And this is done through two capabilities and that are building on top of large language models. So one, large language models have really great reasoning capabilities and they're improving as LLMs are getting bigger and stronger and are seeing more data. And it's operating the same way we as humans do it. So if I give you a complex question like how many times can the UK fit in the US, I ask you to give me an answer on the top of your head, you're not going to get, you most likely won't get it right unless you're a really great geography buff. But we as humans, the way we think about it is we break down the problem into smaller parts. So let me find the size of the UK, let me find the size of the US. what tools do I have at my disposal to find this? Maybe Wikipedia is a trusted source. And then let me do some math to divide the bigger by the smaller. And this is exactly how an agent would reason about it. And there's no magic behind it. You're just literally prompting the model to say, think step by step, create a plan. And then for each part of the plan, you have access to tools. So that's the other part of it, the ability to act and to call on tools. So a tool could be an API that interfaces with Wikipedia. It could be a calculator. It could be a piece of program that can run a script for you. And when you combine all of those together, you're actually giving a lot more autonomy to the model to how to solve the problem. You're not prescripting how the solution would be. The model takes care about how to solve it. And this is what we mean by an autonomous agent. So long answer, but I think this is helpful to contextualize that it's a continuation of where we are with systems design.
Yeah, that's really useful. It sort of feels like we've kind of moved through these 3 acts already, right? In like the last, 24 months, right? Where like, the way you kind of phrased it was the first act was everybody thought we'd have one big model and do inputs, outputs, and like problem solved, right? Like we're done. And then it feels like act 2 was, oh my God, that doesn't work at all. What we need to do is kind of like prescribe all of these steps and then kind of like insert the model into the process. And then I think act 3 is kind of, it sounds like a little bit of where we're going now with agents is, well, we kind of go back to that big model state. But the trick is, I guess, that we're allowing the model to like develop these step-by-step instructions on their own. And then I guess enable them to kind of like reach out and interact with all of these systems. It sort of strikes me that the big challenge here is, can the model actually touch all these outside services? Because, we've had stuff like chain of thought for a very long time. That interface seems to have been the difficult one, right? Which is like, how do you actually get the model to go and interact with all these services? Because I suppose in effect, it's kind of like get the agent to write an API on the fly. Is that kind of how people are approaching it?
Yeah, so models are being trained to be better at generating a correct output to interface with an API or to run a piece of code. There's also actually good privacy and security considerations here when you move to the agentic space. So prompt injections would be quite scary. And then I think I'd pass it on to Kush to maybe talk more about that. But the other part as well is code execution. We've heard from even like, I think the founder of OpenDevin said the first time we run it, like all the systems in the file system were deleted because of like the agent behaving. So you have to be like really careful in how you architect that. And yeah, I don't know, Kush, if you want to comment more on like some of the security privacy considerations with agents.
Yeah, so clearly when these things are interacting with various cyber-physical sort of systems, then there is a risk of the different types of prompt injection attacks, what we call indirect prompt injection attacks, that can either get corrupted because something out in the real world has a problem, or that the models themselves are going out and actually causing stuff bad to happen in the real world. So I think, yeah, I mean, it is a danger, but I think the promise is also really, really great. And I think we can build in some of this security, privacy sort of guardrails into the way that these agents actually interact. And yeah, I mean, as Tim said, I mean, the code itself, like the API code is being generated on the fly, is like the most exciting part about this, because code has traditionally been written for like a fixed sort of thing, but here, if it's being generated, then you can compose things as in a creative way, and I think that's a unique thing.
Yeah, all of these things seem to point to kind of the struggle of deploying AIs in the real world, where, the act 1 that I described is almost like the AI person's dream, where it's like, it's a complete vacuum and we just have one model that does everything completely out of the box, input, output, and we're done. And, each step of this seems to have been like, actually, there's actually all these legacy systems you need to deal with. Maya, is it right from Kush's last comment that this is one reason why agents are potentially really good in the enterprise? Because I guess what I imagine here is, your main worry about agents on like a consumer side is like they're going out into the world and doing all sorts of things. And, they're subject to all of these inputs from the public that might be attempts to manipulate these systems. But I guess in the enterprise, like you control a lot more of the variables, right? You could have an agent that just like operates within a business. And that feels like it might like constrain the problem more in a way that makes agents more viable. Do you agree with that?
Yeah. So I think in general, when you're taking a new piece of technology, especially one that has more autonomy in how it can operate. So starting with low risk areas, maybe back-end services and a company, I think that would be a good place to start, and then gradually exposing it more as you architect systems to safeguard it from threats, or just guardrail its internal behavior so it doesn't end up wiping your system. So I think with all technology, like you start with the less risky place, and then you gradually add more risk to it. And I think that's a sound approach. And then in this world, so I talked about compound AI systems, right? And then there's kind of on the one hand side, you have a programmatic way of doing things. And on the other side is the agentic way. I don't think it's going to be one or the other. The two are going to talk to each other. So for some problems, there's especially for narrow problems where there's a very specific way of solving the problem that's repeatable. You're not going to get something out of left field, a query out of left field that doesn't like fit the solution you have in hand. Go for efficiency, go for the programmatic approach. For problems that there's many ways of solving it, especially like, for example, how to solve software engineering problems. This is where an agentic approach can be easy because there's multiple ways of going through a path to solving it. And these two will come together to solve problems in the enterprise. It's not going to be one or the other. And you're always going to apply a systems mindset of how can I solve a problem most cost efficiently with the right guardrails around it.
Totally. Yeah, it kind of, there's like basically a real big question here on, for a given enterprise, like if you broke down all the tasks they need to do on a given day, right? Like what is structured and what is like requires an agent is actually kind of a big question about how that market's going to separate. Like I don't genuinely know, like if you took an average enterprise in America and you say, let's map all your business processes, do they tend to be quite routine in the way that like, does this sort of like, we just need to do this in this kind of like very systematic, programmatic way? Or does it require like, like the agent to go out and kind of like essentially exercise some innovation? Do you have any early signal on that? Like for the clients that you work with, the people that you talk to, are enterprises still mostly favoring kind of this very structured approach? Or is there like are there particular kinds of businesses that are like, oh yeah, the agent, that's exactly what we need?
Yeah, I would say most enterprises are still in this systematic approach. RAG is a very popular use case. Most enterprises have built programmatic RAG. There's degrees of agenticness you can build into it. So maybe you could have a self-reflection loop. So you could take the output of what the RAG system provided and have the model reason on, is this actually solving the problem at hand, and maybe loop one more time. So we're seeing some companies dabble, but not fully embracing the full autonomy of an agent solving a problem. And for multiple reasons. One is we're trying to understand which sets of problems are better suited for a fully agentic approach compared to the programmatic approach. I have a hypothesis of, if you have a narrowly defined solution that can unlock a lot of business value, let's say it's like you're interacting with a database and there's a narrow set of commands you want to apply, you can engineer all the fallback loops by hand. And if you solve this, you unlock $1 million for the company, go for the programmatic way. And then if you have a system that's going to get so many different queries that there's so many different trajectories to solve it, and you can't even think through all of the different ways this could fail, and running a pilot program, you could uncover some, but there's a lot more to figure out. I think this is where having more autonomy in the system could be useful. But we're still early days, and we're still trying to thread this tension between the two. And I think cost efficiency will come into this equation as well. For some problems, you're willing to spend more for 1% more accuracy. And then for other problems, you're going to be a lot more tighter on what's the right solution to implement.
Well, and isn't there a third dimension on all of this, which is like, what do you want to handle programmatically? What can you start to free up and allow a more agentic approach? But then what always needs a human in the loop, like humans and agents working together, or just humans separately? So curious, Maya, if you have any thoughts on that other layer of it.
I think great agentic systems at where we are right now might need a human in the loop. It would be great to have the system know when to plug in the human. And you could, like with the agentic frameworks out there, you could prescribe for the model to call in a human for help. So I think it depends on like the what is the risk of harm or the risk of failure and the availability of an expert. And I think that's what you would consider of how you would bake it in. I think most autonomous agents we've seen have a strong element of human in the loop. So if you're looking at the GitHub workspace assistants, all of this require you to revise the plan of the agent before it executes it. And then you get to see every step implemented. And you have so many ways for recourse or changing how the problem's being solved. And I think right now we're leaning very strongly in having human in the loop because we're early days and there's many ways this could go wrong. And I don't know if this answers your question as well.
Well, I was just going to ask, are we just waiting for these like agents to get better and better and humans will have to do less and less in the loop? Or, is it less dependent on the model's capability and more dependent on kind of the use case? Like where is it headed? Is there a limit to how much we can abstract away?
Yeah, I think these are great questions. I'm always in favor, me personally, I'm always in favor to have people engaged and for safety. It's an open question of, are these models going to get better at what they do and be able to implement what they need more autonomously? Where we are with the technology right now, you definitely need a human in the loop.
Yeah, I think we're also, I mean, the meta here is that it feels like we're talking a little bit about trust, right? There's a hypothesis I've been chasing after, which is whenever people talk about AI, they're almost like, the AI is coming. And like, what does the AI enterprise look like? But the fact of the matter is like this depends so much on like the culture of a given company, right? And like the degree to which they trust autonomy. And what you should actually anticipate is that like the implementation of like the programmatic approach versus the agentic approach, like where you lie on that spectrum will almost be like totally defined by like how much management trusts the technology and then what their general behavior is. Like I'm curious, like if a company who already is like very structured with its employees and is like, here's the big list of things you need to do, like it will be no surprise that when they implement AI, it will be like programmatic in that way. Right. Whereas you might see cultures of, enterprises that are just a lot more like, well, we just like give people the goals and they sort of figure out what happens. And it will similarly not be a surprise that when they implement technology or AI that they'll say, yeah, actually, we're okay with agents, so long as that there's enough kind of trust in the technology.
Yeah, there's different risk appetites, I think, that we're seeing with companies and larger enterprises. Like we said earlier, you might start in low risk places. So like your HR systems, your backend systems, and then you would bring it more consumer facing. And I think it will be interesting to see this year what would be the appetite of enterprises to adopt more agentic like behavior.
Yeah, that'll be so fascinating to see, especially because I think some of those determinations and even what functions are low risk is going to depend a lot on like what else is happening in the world. Like you can imagine like a very high profile failure, basically totally lowering people's appetite to like implementing agents for a long time. And there's almost kind of like a Google Glass effect where it's like, oh, you have one wearable, which is like an enormous failure in the market. And then it's just like difficult to like convince people to put anything on their face for the next decade. And so there's a little bit of this kind of like crossfade, which is like all these companies are making their own decisions, but it's also in like the soup of like what they're seeing out there in the press and in the open and what their competitors are doing. Well, great. So I think to bring us home, I want to go to our third topic. There was a company that was launched just this week, I think like 48 hours ago, 24 hours ago, by the name of Safe Superintelligence Incorporated. And if you haven't been following this soap opera, the background is that Ilya Sutskever, who is formerly the chief scientist, one of the key players in OpenAI, and played a role in the board drama and kerfuffle that happened not too long ago, was left the company. The circumstances are still disputed, and has reemerged with a new company that promises to finally deliver on the dream of superintelligence. And Kush, I think you kind of threw yourself kind of in front of the bus to kind of talk about this topic. And I guess I'm kind of curious, just as a starter, how big of a deal is this? There's my point of view, which is it's becoming increasingly clear that like in order to play in the AI space, you need very, very, very deep pockets. And, there's kind of a part of me that just sort of despairs at competitiveness in the space where I'm like, I don't agree with Ilya. I'm very skeptical of all the superintelligence stuff. But like, man, if I don't hope that like a small startup can like go up against the big folks, is that even a possibility? Like, Like, does this company SSI have a chance to like become a player in the space?
Yeah, I mean, I think this is just a round of like multiple rounds that are happening where you start with idealism and you then like kind of face the reality or like see the professionalism of it. So
Uh-huh.
OpenAI started with an ideal sort of thing, then Anthropic started with some ideal sort of thing, and now this is kind of the next one. And like I think what's happening is, yeah, I mean, the deep pockets are the important aspect of it. So uh, because you need so much sort of investment to even get off the ground, then at some point the question becomes like, for where the money came from, what's the return that they're getting? It's hard to stay like isolated and only be like a research organization, or like have like that single like, oh, we only have one thing on our roadmap, we only have one sort of goal,
Because
which
like people they want
yeah,
to get paid.
yeah, they do. I think that's right. And like there's this conflict between like scaling and caring. So you can like scale, and that is what I mean. Capitalism is all about. You can care, just focus on like one person, one sort of issue, and then really go deep in that. And like you can't really do both. And so I think that's where the conflict is. And uh, is this going to be successful? Maybe. But I think it'll be just one more round of this. So for a couple of years, 2, 3 years, whatever it is, they'll kind of have their point of view, keep it. But then, yeah, I mean, someone will be at the table asking to be fed. So I think we'll see what
See how
happens.
these two forces interact.
Yeah.
Yeah, I have a friend who is observing, like, you start out trying to deliver on AGI, and then you find yourself being like, we got to do B2B SaaS. Like, essentially, it's
Yeah.
like you're
Mhm.
eventually kind of dragged towards this. Just even if you want to fund the dream, like, basically, like, where the money's going to come from is like these kind of very, like, day to day kind of applications. Krish, actually, we haven't talked about this in the previous episodes. I mean, do you buy their mission? Like,
Mhm.
is the goal of
Yeah.
superintelligence like something we should even be chasing after? Is it a coherent goal? Right. Like I think there's like real kind of critiques that people
Yeah.
have made in that space. But as someone who
Great.
thinks about AI
Mhm.
governance, who's like researching
Mhm.
these issues,
Yeah.
how do you size up, I guess, this idea that like we're going to do a company
Mhm.
where the promise is, yeah, like to an investor even, you put money in
Mhm.
and we deliver on superintelligence, right? Like it's like the old
Yeah.
DeepMind mission, which is like we solve intelligence first, and then after that we solve everything.
Yeah.
You know, is that something that you think is like the
Mhm.
right way of approaching some of these problems?
Yeah, no, it's a great question, and let me like give somewhat of a historical perspective. At least for me, like the first time I heard about superintelligence at all, it was December of 2015. So this was at the NeurIPS conference. There was this whole day like symposium, which they don't do anymore, but there was one. It was this Algorithms Among Us was the title of it, and there were a lot of different things. It was about like the societal benefits of AI, and I mean things that I was thinking like, oh, I would be really interested in. And then I show up at this thing, and one of the presentations is Nick Bostrom talking about superintelligence, and uh, like in this whole like sort of day, like the word safety kept coming up again and again and again, and no one was defining what even safety is, what they mean by it. And I think like I came home, like I tried to figure out what safety means to me. Kind of wrote something about it as well, which was minimizing the probability of harms and risks, and minimizing the possibility of unexpected harms, and this sort of stuff, which then lends itself to kind of more like clear and present sort of harms, clear and present things that affect society now. And then at the same time, in 2016, there was this now famous paper came out, which was these concrete problems in AI safety. So Dario Amadei was the first author on that one, and that somehow like just caught the attention of people. It became kind of like this religious sort of thing that this existential risk, this like big sort of thing for like 100 generations into the future. Like, what is AI going to do to humanity? And I mean, to me, yes, we do need to think a little bit into the future. So there's this concept called the seventh generation principle. So this comes from the Haudenosaunee tradition. And yes, I mean, you can think 150, 200 years into the future, think about what might happen, the consequences. But so far into in advance is a little bit pretentious in my opinion. So superintelligence, there are risks, of course, but I would much rather, both from a personal, societal, and enterprise perspective, focus on kind of what can we do, where do we take things, and where do we protect things now.
Yeah, I think kind of what I'm trying to reconcile is, and it may just be that we end up like talking a little bit about kind of like how the broad universe of AI is going to continue to diversify and look very different in very different places. It does seem like, I don't know, we've spent like maybe the last 40 minutes kind of talking about trends that are like almost very opposite of, superintelligence, right? Or like what Ilya is working on, which is like, turns out a lot of people don't really need huge, gigantic models, right? Like ergo, like what the synthetic data stuff is kind of pushing towards. Like similarly, like a lot of the issues that businesses are dealing with are like, how do we query a database effectively? And so it kind of feels like maybe there's actually going to be this like, these two worlds were very similar for a while, which was, LLMs are going to deliver on superintelligence. And by the way, we can also do B2B SaaS. But it kind of feels like maybe over time, those technical genders are going to go further apart.
Yeah, I think at least from my perspective from the agentic space, the types of agents that are coming out are very narrowly defined to solve a specific task. And then you have instantiations of narrow agents. So an agent that focuses on data analysis, that collaborates with an agent that can do reporting. And this is kind of the path forward that is gaining adoption and traction. And for several reasons, it's more democratic. You can work with open source models, smaller models that you can self-host. So you have full control over the system that you're building. And I think this is the opposite view of the big monoliths that are trying to take a stab at superintelligence. And I think we in IBM research, I think I know which camp we're in. And it's like betting on giving you as developer more autonomy, you being able to control which models you use, trying to use your own data. And the way to go about it is more narrow applications. I have an open question in my head of like how broad and general purpose we can go. And there's a limit to what would be useful to society, like Kush mentioned.
Just echoing what Maya said, I don't think that they are going to be very well aligned incentive-wise moving forward. You just look at where like we're going to be incentivized to develop from the types of tasks you don't need super general intelligence. But I do question, whether this should be developed in a kind of proprietary closed company versus in a more like academic consortium and other groups that might be better incentivized and have maybe better priorities as we talk about like what society could actually benefit from for developing this type of technology versus just like some man behind a curtain with some VC money going at it.
Pay no attention to the man behind the curtain.
Yeah,
it's so competitive, and I think in part like this kind of divergence, like for some of these companies, right? Like so, OpenAI, Anthropic is another good example, right? Where it's basically like very much instantiated by people who like really believe in, want to work on massively agentic systems, right? That are incredibly general purpose. They would call it superintelligence. But in practice, they've also had to kind of just deliver on like the day-to-day of being a business. And it's kind of like, to what degree can these businesses kind of keep these two objectives in line, or like even work on things that achieve both ends? And then kind of the question we're asking is, well, maybe at some point the research and product development agendas here become quite different. Producer Hans actually just dropped that Anthropic just this morning launched a new model in the space. So they've just dropped Claude 3.5 Sonnet. One of the things that everybody's kind of observing or chattering about this morning is that it's actually very similar to what Google and OpenAI have done over the last few weeks, which is speed. They want to launch models that are just very, very, very fast. And it's kind of interesting is like, why do you actually work on speed? Well, it's not necessarily because you think the superintelligence needs to be really fast, right? Like, what you're doing for speed is like, it actually opens up all of these other interesting consumer applications, like, talking on the phone with your AI while you walk along the street. And it's I think a really good example is like, if anything, the recent set of announcements this summer have all been kind of pointed towards the more practical than the more sort of speculative. But yeah, I don't know if the panel's got kind of thoughts on that or if they saw the recent Claude release. I think it was literally like 90 minutes ago. So
No, I haven't seen the Claude release, but I think on that point, maybe a bit in counter to what I said before, what could be interesting, you think about the types of models that we're working with today, the class of technology with transformers, they're not efficient at all. They require huge amounts of energy. Like there's a lot of question whether this is really the type of technology that will actually drive super intelligence. So if we are being more incentivized to focus on things like efficiency and speed, will that unlock and maybe help us discover new types of models, new types of architectures that could serve as a much better basis for potential general intelligence systems?
yeah, that's right. So we actually kind of unexpectedly, like in chasing through B2B SaaS, we actually end up like coming out the other end and being like, oh, I guess we have superintelligence now. Is sort of Kate, like sounds like what you're saying.
Well, maybe it just helps us get a little bit more diverse in where we're investing. But yeah.
Right.
And to go back to something we said earlier about we used to have all this promise in like monolithic models will solve all your problems and will achieve super intelligence. And then I spoke a little bit about how it's actually like systems that are bringing a practical angle. There's some really interesting papers and studies coming out that if you compare like the best in class models like GPT-4o and system approach, whether it's agentic or not, using smaller models, you're actually on like a Pareto efficient curve. You're actually achieving better accuracy than GPT-4 in a much more cost efficient way. And I think when if you're talking to enterprise customers, this is the selling point of you're able to do more accurately and more cheaply. And I wonder if it's like in the future, are we going to get monolithic models that are going to be better and out of the box, or the power is going to come from a systems approach?
Well, and even the definition of like a monolithic model is different. Like we're seeing like, okay, this model is actually, a mixture of experts of like 8 billion parameter models either fused together, but sometimes they can be more independent, So what is a model or a monolithic model versus what is a system model? I think those lines continue to blur.
Yeah, I think we're very much past the monolithic model. Like I think we all can safely say like GPT-4 is much closer to a system than it is to a monolithic model.
Mm-hmm. Yeah, like the era of the big model is actually already over. Like we're not actually in that world anymore. I guess it's also true to fact. I mean, if you're one of those people who uses like the evolution of the human mind as kind of like a projector or forecasting for like where AI is going, there's kind of a view that like the human brain was kind of like kludged together over many like centuries and millennia, with just like one piece being bolted onto another piece, bolted onto another piece. And so in some ways, it's kind of no surprise that if we're working on general intelligence, something that resembles a human mind, that you'd actually end up with a model ultimately that is like a bunch of pieces running around. It's like a bunch of kids in a trench coat actually is like how we achieve general intelligence.
Yeah, and even the safety work that Ilya, was leading on the super alignment, where it's a smaller model that's kind of controlling the bigger model and making sure it doesn't go haywire is, again, this sort of architecture, this sort of view that, you're going to have a bunch of things working together. So, the way they described it was like this weak to strong generalization. So you have a weak model that's controlling the strong model. But I think a better way to think about it is like a wise model that's controlling the strong model. So there's some aspect of wisdom that's coming in. Different properties of different components can actually keep things under control as well. So just like our wise host Tim here keeps all of us under control. So I think there's roles. There's reasons for all of us to exist and kind of work together. So.
Yeah, that's great. Well, thanks all listeners for joining us again. Please join us next week. And as always, if you enjoyed what you heard, you can get us on Apple Podcasts, Spotify, and better podcast platforms everywhere. So Maya, Kate, Kush, thanks for joining us and hope to have you back on the show at some point in the future.
Cool. Thank you.
Thanks, everyone.
Thank you.
That's great.